in order for us to, develop the energy balances that we're going to use in order to account for the flow of energy into and out of processes, I first want to introduce perhaps the most fundamental law for this course, okay? And so what I'm going to introduce is the first law of thermodynamics. All right. And so what this law states is that energy is conserved. Similar to how mass is conserved, and that allows you to, develop material balances to calculate the flow of moles or mass into and out of a process. The first law of thermodynamics is going to serve the same function for us. It's going to tell us that energy is conserved, and this will allow us to develop our energy balances. Now, I do want to point out kind of one, small subtlety with this law, is that when it says that energy is conserved, it's referring not just to an isolated system, but it's referring to both the system and its surroundings. Okay? And to visualize this, I'm first just going to draw, let's say we have some sort of arbitrary system, right? And the boundaries of the system are bordered by this dashed line, okay? And so when I say system, I'm just referring to everything within these dashed lines, okay? So that's our system, all right? And our surroundings, what I mean by that is it's everything outside the system, right? And so surroundings is just whatever is outside this border. Now, let's say that in our system, for some reason, there's a net transfer of energy outside of the system, okay? All right, and so if we just considered the amount of energy in the system, or the change of energy, right? That change of energy would be negative. It'd be less than zero, right? Because energy is leaving the system. Right? But if we consider the transfer of energy from the surroundings perspective, so delta E surroundings, right? The energy that's leaving the system is going into the surroundings, right? So the delta E for surroundings is going to be positive. It's going to be greater than zero, okay? And so here it's negative, here it's positive, right? But if we consider both the system and the surroundings together, E system plus E surroundings, what the first law of thermodynamics says is that this sum has to be exactly equal to zero, right? Because the total energy in the system plus surroundings is conserved, okay? And so this is going to be an important principle that will allow us to develop the energy balances that we use in the rest of the course.